Okay, today we're going to talk about solving quadratic equations by finding square roots. And so the first thing we want to do is we want to make sure that we're recalling what square roots are and what they do. And so if b squared equals a, then b is a square root of a. And so what we mean by that is the square root of 9 equals 3, because 3 squared is 9. Remember that number that is underneath the radical sign there is called the radicand. Really, when you do the square root of a number, all they're asking is they're pretty much saying, okay, what number do I take times itself to get 16? And so you're really looking at what can I take times itself to equal 16? And so that answer would be 4, because 4 squared is 16. Now we do want to remember some things here. When they just give it to you like this, really what they're asking for is they're asking for the positive root. They're saying, what's the positive root of 16? And what I mean by that is there's actually another number where if you apply that same idea there, there's actually another number that you can multiply times itself to get 25, and that number is -5. Now the way they will ask for that root though is they'll put a negative sign on the outside, and so they'll put the negative sign there pretty much saying we would like the negative square root of 25, and so the negative number that you can multiply times itself to get 25, and again that number would be -5. The last way that they could ask for one is they could put plus or minus on the outside of it. If they put plus or minus on the outside of it, they're saying we want all the roots. We want both the positive and the negative roots of 81 here. And so they would either give that to you in the directions, or they would give it to you by putting the plus or minus here that they want all the roots. If that is the case, you can either give your answer as 9 and -9, or a lot of students have liked using this symbol here. This is the plus or minus symbol, and you can put that in the front of it, meaning that it could be +9 or -9 there. So be prepared to read the directions there. Make sure you know whether it wants the positive root, the negative root, or all the roots. Now, these are all examples of perfect squares. Anytime you have a situation where it comes out nicely like this, that's an example of a perfect square. So if it comes out to be an integer, it's a perfect square. Also, if it comes out to be a rational number, it's a perfect square. An example of that would be 1.44. Now remember, an integer was just these nice numbers here and their negatives. And so these are all integers because there's no decimal or anything like that. When I say rational number, remember a rational number is just a number that you can write as a fraction. And so if you look at the square root of 1.44, you can multiply 1.2 times 1.2 to get 1.44. That means the square root of 1.44 is 1.2. If I wanted to, I could write that as a fraction, 1 2/10 there, or 1 1/5 I should say. And so when you can write it as a fraction, it's a rational number. If it comes out as a rational number, these are considered perfect squares. If you have a terminating decimal here, it's a perfect square. There are going to be situations where you take the square root of something like, for instance, the square root of 5, and when you take that on the calculator, you'll get this really long decimal there. And so you'd be working through it, and it'd be this really long decimal, and it'd go the whole length of your calculator screen. When that happens, those are called irrational numbers. And what you'll find is, if you do not have a perfect square, then the answer will always be an irrational number. It will go forever and it will not repeat. It's just like pi. Pi is an irrational number. It's just equal to 0. That is your standard form. We're going to look at solving some of these problems here. I'll show you just kind of an easy one here quick with x squared equals 16. When we're trying to solve x squared equals 16, remember our goal is always to solve for what x could be. Now the thing you might be seeing here is on this particular problem, x is going to have multiple answers. But my goal is the same. I need to get this from x squared down to x. And so in order to get from x squared to x, I got to look right here to see what to do. And to see what to do here, what we're actually going to do is we're going to take the square root. Now if we take the square root on the left side, we also have to take the square root on the right side. The reason this works, remember with the square root, it's pretty much asking you, what do you take times itself to equal x squared? What do you take times itself to get the radicand, x squared? Well, the thing I take times itself to get x squared is just x. X times x is x squared. So now I do the same thing on the other side, the square root of 16. Now the square root of 16, remember here, is 4, but we're going to want to put both roots there, plus or minus. So technically here I should really have a plus or minus here and a plus or minus here. A lot of times I don't write those on there. I just realize that I need to give both roots. But there are two possible answers for x, plus or minus 4. Now they can give you a little bit of a tougher problem here if they want to. and so they can put other things involved with it. Our focus is still on the x squared there. And so I want to get rid of the 160. I want to divide by the 12. And I get that x squared is 5. Now, I don't want to know ultimately what x squared is, though. I want to know what x is. And so I take the square root. Now, when I take that square root, again, the square root of x squared is just x, so that works out great. If I want to give an exact answer, if I want x equals, I got to make sure I put plus or minus on there. It could be the positive root or the negative root of 5. And so make sure you know whether you want exact answers or rounded answers. If it was a rounded answer, then I'd go through and I'd figure out what the square root of 5 is.